All right, great. So, so again, we're finishing up this ratios and rates handout. We saw a video on grit. And then, oh, also effective studying. It's not just doing the problem. Like, I think doing the problems helps, but also explaining, talking, because having to put. Remember we talked about earlier in the semester how it's harder. Did we talk about this? Mm-hmm. Yeah, it's easy. It's harder to like put things into words to explain to somebody else than it is just to know it. So the act of having to like translate it into words that you can explain to somebody else, even if it's just like your friend or your mother or your teddy bear, whatever, having to talk and explain it to somebody else forces you to create that clearer mental structure so you can store it into long-term memory better and retrieve it easier. That's kind of one of the key things. So that's why this talking is so important. All right, so let's go take a look at those ratios and rates. Which is a better buy? So again, remember this is cost per item. So 12 for $10, so $10 for 12 of them, 12 cans. It equals how much per can?
28 cents.
28 cents per, really?
It's 3 12 can packs.
3 12.
Oh, 3 12 can
Yeah.
packs. I'm sorry.
Yeah, so 36 cans, yeah.
3 times 12 cans, so it ends up being 10 over $36 in cans. My bad. That makes a lot more sense. I was like, that's really expensive. So it ends up being 28 cents per can.
Yeah. Well, I rounded, yeah, but 28 cents.
Okay. All right, we'll go with that, I suppose. It's probably fine for this one. And this one here is $5.79 for 20 cans. And that ends up being how much?
28 cents.
21 cents a can?
29.
29 cents a can. Okay, so you might have something more specific. Natalia, what'd you have? You rounded?
Well, for the 36 cans, I got 0.27, and for the 20 pack, I got 0.28.
0.27 what? Sorry,
Cents.
I should look at this. So 10 divided by 36. It's 277. Right, so this becomes 0.27. You can round. If you round, remember you gotta look at the next digit. So since it's 0.2777, you know, dot, 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 then we kind of have to look at the next decimal and see that this is, because this is between 0.278 and 0.277. Does everyone kind of agree with what I'm saying? Is that this is making sense?
Mm-mm.
All right.
No.
So our number is 0.2777 dot, dot, dot.
But our number's 2.2895, right?
Well, this is a number from the calculator. If I do 10 divided by 36, I get 0.27777 on and on and on.
Okay.
So that's, if I'm going to round to
Right.
the nearest, say I round to the third decimal place, then that's going to be between 2777 and 2778. Does everyone kind of agree that 2777777 is between those two numbers?
Hmm.
Right?
Yeah.
Okay. So I'll look at the next one. When you round, you gotta look at the next decimal place. So I'm gonna look, if I'm gonna round to this one, I'll look at this one. Then I'll do that in different colors so it's not so confusing. And that one tells me whether it's closer to the 8 or the 7. If it's 5 or more, then I should round up. If it's 4 or less, then I'd round down to the 277. Which one am I gonna round, up or down?
Oh.
Up. So this would be 0.278. And then the section over here, 5.79 divided by 20 is 2895. So, yeah, that would actually round to 29290 even at 3 decimal places, because we look at the next one.
Can I ask a question?
Yeah.
So we're dealing with cents here, which we can't break down,
Yeah.
you know, cents, so why
Yeah.
would we
So
round
I
to
think
3
it's totally
instead
fine
of
to leave
2?
it. I think it's totally fine to leave it like it is.
Okay.
Yeah, I was just pointing out. But you know, sometimes, if you look at the, right, if you're saying, hey, you got to pay me back for this can of soda, it's 28 cents.
Right.
You would do that.
Yeah.
Yeah. Okay. So which one's a better buy? The 3 12-packs, yeah? 3 12-packs. And you'll find that's true a lot of times. Like if you go to a store, like a lot of times, you know, they have these things like, oh, buy one, get one free. And it's like, well, okay, so one is like $7, so then it being $3.50 each, which is not that bad. It's not that bad. But when you go to, but then you go to, you get them on sale and it's like 3 for $10. That's super cheap. I always stock up on the Coke when it's 3 for $10. Very good deal. All right. It's the weekend. You must have a bag of chips. Rush to the nearest grocery store and pick up your favorite brand. The cost is $2.79 for a 5.5 ounce bag. So $2.79 for 5.5 ounces. That's your favorite brand. Then there's retailer has a special on a different brand that's normally $3.29 for 5.5 ounces, but it's buy one get one free. So this is $3.29 for 2 5.5 ounces bags, right? So it's 11 ounces. So everyone sort of follow. So what are the two costs on that one? What did you folks get for the? So make sure you round. Everyone redo it. Make sure you round to the right decimal place. This is 30 cents per ounce. And this one is, everyone find it, do it. Ooh, 51 cents per ounce. Okay, so clearly this bag is less expensive, but what would you do? Would you buy your favorite? I mean, there's no right or wrong answer. Just as long as you put any amount of thought into it.
Yeah. I would stick with my favorite because the 21-cent savings for a bag of chips, per ounce is not enough to make me take a chance on something that I wouldn't like. So,
okay, so you stick with your favorite?
Yeah.
You must have a different answer? I don't care. I'd probably go with the cheaper one because I don't care that much about the chips, I guess. Kind of depends, right? So it sort of depends. There's no right or wrong answer in that one. Just have something down. Okay, great. So now, the wonderful tutor has brought in our handouts. So we're going to go into Intro to Rational Functions. Intro to Rational Functions, not this one. Ooh, incidentally, in this section, did you hear what she said? Varies inversely. We found that grit. Is not correlated with talent. In fact, sometimes it's inversely. It's either not related or inversely related. And we're going to do inverse variation in probably next class. Or if not, on Monday. Or no, not Monday, after Thanksgiving. Okay, so rational function models. Translation of rational function models. Intro, here we go. Intro. Perfect. Those folks in that half of the room. I'll get this half of the room. Pass that down. All right. Excellent. So, now we get to do rational functions. So rational functions are of a form where you have some polynomial over another polynomial. So what's a polynomial? Or a monomial even is fine. It's something where you have, okay, so let me give some examples. So this is a polynomial. That's a polynomial. Everybody agree with that part? This is not a polynomial. Well, I suppose in theory, if you extend it out, it could be a polynomial. So maybe that actually might qualify. Okay. This is also a polynomial. Actually, technically it's called a monomial. Everybody okay with that part? This is also a polynomial. Good. I can add this to it. Still a polynomial. Everybody are with all those sorts of things? So it's where you have terms. The top one has 3 terms. The middle one has 1 term. The bottom one has 2 terms. Everybody all good with that, with this stuff? Yeah? Okay. So all a rational function is function where you have a polynomial over another polynomial, and q cannot be 0. The basic one, the one we're going to be working with most, is this little guy right here. F of x equals 1 over x. So this is y equals 1 over x. This is what it looks like. So see the dotted lines? Here and there? They're there for a reason. If you look at the graph, do you see kind of what's going on with it? What's the domain of this basic rational function? So here's my rational function. What's the domain? This goes all the way on and out forever to the left. This goes down forever and ever and ever. That goes up forever and ever, and this one goes right forever and ever.
Negative infinity?
Yeah, so it starts off at negative infinity. Yes. So this goes off to negative infinity this way. Oops. This goes down to negative infinity. This goes up to positive infinity. This goes out to positive infinity in that direction. Okay, so thank you for that excellent observation. Now, my domain, as you said, is going to be negative infinity. It's going to start off at negative infinity. That's true. And where's it going to end? To the right. Where's it go off to the right?
Oh, infinity.
Positive infinity, yes. But here's the catch. There's a spot in the middle where it can't be. It can never ever be what?
0.
Yeah, and it gets closer and closer to 0, but never touches it.
Oh.
It's like a kid, right? It says, I'm not touching you. The little neighbor, the brother or sister. They get closer and closer, it doesn't touch it. Here it gets closer and closer to 0 in this direction, but doesn't touch it. So, it's from negative infinity up to 0, doesn't touch 0, and then hops over 0 and goes from 0 to positive infinity. So, it's like this. Negative infinity to 0, or 0 to positive infinity. The union of those two groups. Remember that U is union. What's its O? Do you want the easy way of writing it? Here's the easier writing it. So we're going to assume that it's all real numbers unless otherwise specified. So here I'm going to say x is not equal to 0. What that means is, if I say x is not equal to 0, that means it's everything else, but. Can't be 0, but it can be anything else except for that. Everybody all right with that part? All right, what about the range? I'm going to look at the range. What do you think about the range? How far down does it go? How far up does it go? Any restrictions? Talk to your neighbors if you need to.
Which is the same. Everything but 0.
Aha.
Can't touch 0.
X equals not equal to 0.
Right, so Eric, you said what?
I think it's the same as the domain. It's x is not equal to 0.
Yeah, it's everything except for 0. It gets closer and closer to this dotted line, but doesn't touch it. Someone fall in with that? that making sense for folks? Okay. Some feedback, thank you. So the range is also negative infinity to 0, union with 0 to positive infinity. And again, these are all going to be rounded brackets because you cannot touch 0. Or you could just say y, right, not x, y is not equal to 0. Make sense? Y can be anything else except for 0. Great. So,
Could you write it as negative infinity to 1, including 1, and then union it on the other side with the 1?
it's not 1 though.
Oh, okay. It's not,
It doesn't,
okay, it's
doesn't
less
touch,
than-
it touches 1.
Okay. Oh, I got you.
It doesn't, it's 0 that it doesn't touch.
Yeah. Okay.
Yeah. Yeah. I think you're getting the right idea, I think. Is the graph increasing or decreasing from negative infinity to 0? So remember the interval, this interval, whenever we're talking about the intervals, we're talking about our inputs. Right, on the interval, negative infinity to 0, for the input of negative infinity to 0, inputs are what? Our x's or our y's?
X.
X's. So for x's are negative infinity to 0, what's up with the output, the graph? Increasing or decreasing? Is the output increasing or decreasing? So here, as I go along from here to here, is my output increasing or decreasing? Is my y increasing or decreasing? As I travel along here, is my y going down or up? Down. Decreasing. How about from here to here? As I travel from 0 to positive infinity, am I going down or am I going up? Down also. They're both decreasing. Why is that? Because one starts off at 0 and goes to negative infinity. The other one starts off at infinity and goes down to 0. So it can have its cake and eat it too. You can do it on both ends.
How do you decide where it starts?
You start from the most left, from 0 to infinity. So so you start from, you read a book from left to right.
Okay.
So as my x goes from left to right,
Okay.
and then again as my x goes from left to right.
Okay.
Yeah. Good questions. All right. So rational functions can take many different shapes. They won't all be as simple and straightforward as this one up here. But sometimes I'll break some of those above, sometimes they won't. The breaks in the graph are closely related to the domain of the function. So looking back at this one, the domain is everything except for x is 0. Everybody remember that part? You have it written on your sheet right here? Right, it's everything except for x is 0. What are the things you can never ever do? Oh. What are the two things that you can never ever do? Can never ever divide by 0, right?
Mm-hmm.
What's the other thing you can never ever do?
Square root of a negative number.
Take square root of a negative number. So you can never ever divide by 0. Do I have any square roots going on with this one? No. But am I dividing by 0? Am I dividing by something with x in it? Yes. So the bottom, see where x is, the bottom can't be 0. The bottom is just x, so x can't be 0. And that's where that domain comes from. So that's why the domain for this function is not all real numbers, because you cannot, you're dividing by something with x in it. Okay, cool. All right, so here we're going to use a graphing device to show each of the following equations. Don't worry about the parameters. What we're going to do is, I will do it on here since you folks don't have a computer. So you could bust out Desmos on your phone, if you like. Totally works too. Desmos, graphing calculator. So I'll put the first one in. 1 over x minus 2. There it is. All right, so everybody should decide. What are you deciding? I'm sorry. What are we studying? Oh, graphic. No. Yes. Sketches. So it looks like it kind of goes off, along the zero axis here. Here, I'll put in some things that might help you. X equals 2. And y equals 0. So that might help a little bit. Here, I'll do this too. We'll make this settings. No minor grid lines, but should be step 1. Step 1. There. Does that help a little bit? So you can see that you can see these points here and there. So it kind of goes through like this, like 3, 2. But you don't have to be super exact. Just do the best you can with it. But it does go through. The point that. So this is 2, 0. Yeah, so go through. So, put your dotted lines in. So that's what I would say. Put the dotted lines in. So see where I have this green line? Make that a dotted line and put that in. I used to know how to make it a dotted line. I don't know how to do that anymore. I have to figure it out. Dotted.
I didn't know that you can do that.
Yeah. There's lots of neat things you can do with this. It's really cool. Oops. It's hard to see that one because it's so it's right on the line. Alright, so dotted line here, dotted line there, right at the 2s. I would do that. I would draw those in. That would make it easier. This one? Yeah, it's in here. Just move that over here, that's right. Or just draw a line over there, that's fine. Good. Good. All right, so everybody has that one in. Now we'll do the other one.
What does the dotted line represent?
It represents what you can't touch.